Welcome to the Global WarWatch Network. Lockheed Martin just revealed its brand new stealth combat drone, the VECTIS, potential game changer built for the future of air warfare. Today, we are taking a closer look at this platform. It's from their legendary Advanced Development Programs division, Skunk Works. We're focusing on this new autonomous drone, the VECTIS Collaborative Combat Aircraft, or CCA.
Yeah, and this is more than just, showing off a model. This is Lockheed positioning itself. They want to be a key part of the U.S. Air Force's next generation air dominance strategy, NGAD, as it's called. And you need to understand, this NGAD strategy, it's huge. It's about transforming the whole force. The Air Force is talking initial fleets of maybe 1,000 autonomous wingmen flying alongside about 500 crewed fighters.
So like F-35s and whatever comes next, the sixth-gen jets.
Exactly. So VECTIS is Lockheed's calculated bet on what that future force needs at the high end.
Okay, let's start with where it comes from. Skunk Works. I mean, that name carries weight. SR-71 Blackbird, F-117 Nighthawk.
Absolutely. They're known for innovation, for building groundbreaking stuff, often quickly and in secret. And VECTIS seems to fit that mold. It's a self-funded CCA. That means they started building it before getting a specific government contract for it.
Interesting. And designed specifically to fly with fill-gen fighters.
Right, to pair with and boost the capabilities of things like the F-35 and the F-22 Raptor.
And the speed. You mentioned speed earlier.
Yes, that's a key point they're stressing.
Yeah.
The program is apparently well underway. They've confirmed the prototype is, quote, in progress. Major parts are ordered. Skunk Works has set this incredibly aggressive timeline. They want to design, build, and actually fly this thing within 2 years.
2 years. So first flight, maybe 2027.
That's the target. It suggests they're probably using a lot of mature tech they've already, worked on behind the scenes.
Now, what's really fascinating here is the strategy behind it. Because Lockheed's first shot at the CCA program, Increment 1, well, it didn't pan out right.
That's right. Reports suggest their initial bid was seen as too gold-plated.
Gold-plated, meaning too advanced, too expensive for what the Air Force wanted at first.
Exactly. For Increment 1, the focus was really on getting numbers out quickly. Cheaper, faster platforms. Maybe less capable initially. Lockheed's offering was apparently too feature-rich and therefore too costly for those first requirements.
So if that bid failed for being too high-end, why double down on another high-end platform with VECTIS? Seems counterintuitive.
Well, because VECTIS isn't really aimed at Increment 1 anymore. It's strategically positioned for Increment 2. That's the next phase, expected to demand much more capable, more survivable CCAs.
Ah, okay, so they're playing the long game.
Precisely. The Air Force knows they'll eventually need these more advanced drones. Increment 2 platforms will likely be maybe 20 to 30% more expensive than Increment 1. Like higher stealth, better sensors, more capability. Lockheed is betting that the real future market is for a platform that is, as they put it, survivable, lethal, and reusable.
And that's the niche VECTIS is designed for.
Exactly. They're aiming to define that next tier of capability, not just compete on the entry-level specs.
All right, let's get into the tech specs a bit then. What is VECTIS, technically speaking?
Okay, so it's classified as a Group 5 unmanned aerial system, a UAS. For you listening, that's the top category for military drones. Max takeoff weight over 1,320 pounds, flies high, above 18,000 feet.
So not a small drone by any means.
Not at all. It's a serious aircraft. Size-wise, think somewhere between, say, a large cruise missile drone and a smaller fighter like an F-16. It's substantial.
And looking at the concept art, the design just screams stealth.
It absolutely does. Low-observable technology, or LO, is clearly paramount. You see that modified delta wing shape, sometimes called the lambda planform, fewer sharp corners for radar to bounce off.
And it's tailless. That's significant for stealth, isn't it?
Very significant. Similar to concepts like the X-44 Manta. Removing the tail surfaces dramatically reduces radar cross-section, especially from the sides and rear. But you have to look closer at the details. The LO shaping is quite sophisticated. There's a dorsal air intake sunk into the top of the fuselage that shields the engine fans from ground radar.
Okay, I see that. And the sharp edge along the side.
That's called a chine line. Helps manage radar reflections. Plus, they mention things like S-shaped internal ducts for the engine air and shrouded exhausts. It's all about minimizing radar detection and hiding the heat signature from infrared sensors. Makes it very hard to spot.
So it's stealthy. What's it designed to do alongside those fighters?
It's pitched as truly multi-mission capable. The simulations they've shown have it doing air-to-air combat.
Firing missiles.
Firing missiles, yeah. But also air-to-surface strikes, ISR, that's intelligence, surveillance, reconnaissance, and electronic warfare. It's meant to be a real wingman, carrying extra payload, extending sensor reach, jamming enemy systems, not just a flying sensor pod.
Does it need to be supersonic to keep up?
That's an interesting point. While it needs to be compatible with 5th-gen speeds, analysis suggests actually going supersonic isn't the top priority for this kind of role. Endurance, range, and especially stealth seem to be the main drivers. Staying hidden and staying on station for a long time is key.
Now, you mentioned something earlier about open system architecture, OSA. Why is that important here? Sounds like technical jargon.
It's actually really important for the bigger picture. Think of OSA like agreed-upon standards for the drone's internal systems, like having USB ports instead of everyone using a different plug.
Okay.
It means the hardware and software aren't permanently locked to Lockheed Martin. The Air Force, or even international partners, could potentially plug in sensors or software from other companies later on.
Ah, so it prevents vendor lock-in.
Exactly. It gives the Air Force flexibility to upgrade and customize the fleet much faster and potentially cheaper. Critical if you're managing, 1,000 drones needing constant updates.
Which brings us back to that scale, 1,000 CCAs. That's the initial plan. For 500 manned jets.
That's the ratio they're discussing, yes.
Yeah.
2 CCAs per manned fighter initially. It shows the scale of ambition. And the billions allocated to NGAD over the next 5 years, it proves this is not just a concept. It's a major funded overhaul of air power.
And part of this involves a shift in thinking, right? Away from the word attritable.
Yes, the Air Force now prefers the term affordable mass.
What's the real difference? Attritable sounds like it's okay to lose them.
Well, that's sort of the old idea. Cheap enough to be disposable. Affordable mass is a bit different. It means the drone needs to be cost-effective enough to buy in large numbers, yes, but it's still a capable, valuable asset. Crucially, it's intended to be reusable. VECTIS fits this perfectly. It's high-end, designed to survive and come back.
So losing one would still be a big deal, just maybe not as catastrophic as losing an F-35.
Precisely. The decision to risk it is a tactical one, based on the mission, not because it's designed to be thrown away.
And these drones need to operate reliably, especially thinking about vast areas like the Pacific.
Absolutely. That ties into the Agile Combat Employment Strategy, or ACE. ACE, it's all about operating from smaller, dispersed airfields, maybe with less support infrastructure. So the CCAs need to be reliable, easy to maintain.
VECTIS is runway dependent, though.
Yes, based on the design. But Lockheed emphasizes it's designed for high reliability and easier maintenance to support that kind of faster-paced distributed operation. And remember, this all hinges on advanced human-machine teaming. One pilot in an F-35 potentially directing multiple CCAs through, like, a cockpit touchscreen.
That interface is key. Okay, let's zoom out to the strategic level. Lockheed specifically mentions range for the Indo-Pacific. Why is it so critical?
The tyranny of distance, basically. In the Indo-Pacific, bases are few and far between. The ocean expanses are just enormous. Any aircraft, manned or unmanned, needs incredible range and endurance to be effective there. If the CCA can't match the reach of its manned partner, its usefulness plummets.
So VECTIS is designed with that long reach built in.
That seems to be a core design requirement, yes, to function effectively across those huge operational areas.
But this push for high autonomy, for lethal drones, it's raising some serious questions, isn't it? Ethical, legal concerns.
It absolutely is, and it should. When you have systems with high degrees of autonomy, potentially making lethal decisions, it bumps up against international humanitarian law, particularly the principles of distinction telling combatants from civilians and accountability.
How so?
Well, the concern is about speed and complexity. Can an algorithm operating at machine speed always make the correct distinction in a complex, ambiguous battlefield environment? And if it makes a mistake, who is truly responsible? Where does the moral responsibility lie when the human is further removed from the direct decision to use force?
Yeah, the accountability question seems huge. Is it the pilot who launched it? The commander? The programmer?
That's the heart of the legal and ethical debate. Defining intent, or mens rea, becomes very blurry. There's also the worry that the sheer speed of autonomous action might lower the threshold for engagement, make it easier, politically or psychologically, to resort to force.
Increasing the risk of miscalculation or escalation because the human pause is reduced.
That's a significant concern, yes. Removing the human from that immediate observe-orient-decide-act loop could have unintended consequences in a crisis.
So, wrapping this up, what does the VECTIS reveal really tell us about where air power is headed?
Well, it seems clear Lockheed Martin sees the future in these high-end, survivable, autonomous platforms. VECTIS is their big bet on that. It's self-funded, pushing stealth, aiming for Increment 2, positioning themselves as a key provider for that planned 1,000 drone fleet. It's about quality and survivability.
Definitely. VECTIS signals that sophisticated, reusable CCAs are seen as vital for future air dominance. But it also sharpens the global debate. As companies push these highly capable and likely expensive autonomous systems, we really have to ask what level of autonomy is acceptable and what's truly affordable when you need mass. How will nations ultimately balance the cutting edge of capability against the essential ethical safeguards and, frankly, the budget? That's the question looming over all of this. A crucial question indeed. Thank you all for joining us for this look at the Lockheed Martin VECTIS. Please remember to like, share, and subscribe to the Global WarWatch Network. We really appreciate your support. Let us know your thoughts on VECTIS and the future of autonomous warfare in the comments section below. And do join us on social media. You'll find the links in the description. Thanks for tuning in.